Using the matrix method, solve the following simultaneous equations. So we have 3x minus y equal to 11, 4x plus 3y equal to 32. So we are using matrix method. So our equations are 3x minus y is 11, 4x plus 3y is equals to 32. We have to extract our matrices from the two equations. We shall have 3, -1, 4, 3. Then we follow this by xy. And this should give us 11, 32 in that format. So you have to extract the coefficients of x and y to form the matrix. Then you follow by xy, and then you write the right hand side as a column matrix. After this, remember the method to solve these equations. After extracting, you find the inverse of this matrix, then you multiply with it both sides. So we are going to find the determinant of our matrix. Determinant is given by the principal diagonal, that is the product of these two, minus the product of these two. So that one gives us 3 times 3. We subtract 4 times -1. This will give us 9 minus 4. Minus and minus gives us plus, so 9 plus 4. This gives us 13. That is the determinant. To find the inverse, that is the inverse, we take 1 over determinant. Let's write our determinant, which is 13. And we multiply with, what we do, we exchange the values in the principal diagonal. Then we change the signs in the other diagonal. So this will give us 3. 4 becomes -4. 1 will be 1. And we have 3, because in the principal diagonal we have 3 and 3. So that is the inverse. Then we multiply with this inverse both sides. So when we do that, we shall have 1 over 13, 3, 1, -4, 3. We multiply with 3, 4, -1, 3, xy, and this will be equal to the inverse also times the right hand side, 1 over 13, 3, 1, -4, 3 times 11, 32. After that, when you reach this step, you don't have to multiply out. You can use this method. We know we have these conventions that when you have matrix A multiplied by its inverse, as we have this matrix multiplying it with its inverse, we get an identity matrix. And also, when we get the identity matrix, then we multiply with our matrix, with any matrix A. It can be A or B. we get the matrix itself. So that means when we multiply this inverse with its matrix, we are going to get an identity matrix. So in this case, we get an identity matrix, and that identity matrix, which will be 1 0 0 1, we multiply it with xy. This will be equal to 1 over 13, 3 1, negative 4, 3, 11 32. After multiplying this, we shall get the matrix, which is xy, because of this. After that, we have now to compute the right hand side. Let's multiply these two matrices, then we multiply with 1 over 13 at the end. So we shall have, when we multiply the two, we shall have we shall multiply every row of this with this column. So we shall get 33 plus 32, then negative 44 plus 96. Remember, this is multiplication of these two. Then we have to multiply this with 1 over 13. So we have, let's have it here. So we shall be having xy, which is equals to 1 over 13 multiplied by this matrix. Let's add 33 with 32, then negative 44 with 96. We shall have 65 and 52. We shall have 65 and 32 because this is negative 44. So in that case, let's multiply this with our scalar 1 over 13. So 1 over 13 times 65, we get 5 because it is 65 divided by 13. And for the 52, we shall have 4. So lastly, here we have xy being equal to 5, 4. So using matrix equality, matrix equality says that the element in a particular position equals the element should be equal to the element in the same position in the other matrix. So it means that x should be equal to 5 and y should be equal to 4. And this becomes the solutions for our equations. You can substitute back in our original equations and you will find that left hand side should be equal to the right hand